We'll recall the initial part of the mathematical analysis of the free vibrations, which we were discussing earlier. Okay, now we assume that m is the mass of a particle, and there is a restoring force that is acting on a particle which is under free vibration. That is F is equal to minus mu into y. So already we have seen that in case of a free vibration, the force acting on a particle or the body is proportional to the displacement. So more displacement, more force. So that's why F is proportional to y. In order to make the proportionality sign, and in order to replace that sign by equal to, we'll put mu over there. Okay, and F becomes equal to mu into y in such case. And just to make sure that the force and the y displacement are opposite to each other, we will put a minus sign as well. So this minus sign is an indication that the force is opposite to that of the displacement y. That's why it is minus. Okay, so we use these standard notations for our calculations. Okay, moving further. Now we can see that in order to eliminate the proportionality sign, we put a mu, and that mu is called as a proportionality constant. Okay, then the y is axis of vibration or the displacement along y axis, right? Then as I mentioned, negative sign, we'll talk about that. It's actually opposite direction is indicated by using that. Then we know that there are two kinds of forces, right? One is mass into acceleration. So mass of the particle is known, and this is equal to m. And the acceleration is not known, but displacement is known. Displacement is y. So when y is the displacement of an object, we can directly convert the displacement into activity, displacement into acceleration by simply taking the second derivative of that. So d square y by dt square is the acceleration. So we'll call this equation number 2. So now the whole system has a single force that is denoted by F, but this F has two equations, that is equation number 1 and equation number 2. Okay, now since there is a single force that is present here, the equation 1 and equation 2 should be equated. And when we equate this, let's see what happens. So one equation says that m into d square y by dt square is equal to mu into y, and it is minus of that. So we'll take m, the mass, to the right hand side of the equation. That becomes minus mu by m into y. So that the omega square, it becomes equal to mu by m. We have a substitution. Omega is called as the angular frequency, right? Then let's move on. So this gives us the d square y divided by dt square is equal to minus omega square into y. And this minus omega square into y will bring it to the left hand side to make it positive. So you can see that this is d square y by dt square. Minus becomes plus, so plus omega square y, and this is equal to 0. So second order homogeneous differential equation is equation number 3. So in order to solve this, right, we have multiple options available, out of which one of them is just guessing a value of guessing an expression for this. So the solution, we know that it is in the specific format. It is always in this format. Okay, so the format is like this. It is e to the alpha t. Y becomes y will look like e to the power alpha t. So when the root is guessed in this format, e to the power alpha into e to the power alpha t, right? Since this is a root, this should satisfy the original equation which is given. So for that, what we do, we write dy by dt is equal to y into the derivative of that. So y into e to the power at. First equation. At the same time, you have second equation that says that when y is equal to say the 3 by 4. In that case, we will calculate dy by dt is equal to alpha e to the alpha t, and d square y by dt square is equal to alpha square into e to the power alpha t. So differentiate once and twice and call that equation as number 5. Okay, then let us substitute this back in the original equation. So in 3, if you substitute these two, you can see that wherever we have d square y by dx square dt square, we'll write alpha square e to the alpha t plus 1 alpha will be kept as it is, and the second function is 1 power less than the original. Okay, so that we can write it as, so alpha square e to the alpha t plus omega square e to the alpha t is equal to 0. Okay, now take alpha e to the power alpha t a common variable. So when that happens, you are left with alpha square plus omega square, this whole thing becoming equal to 0. But we know something. So that is e to the power alpha t is not 0 in this case, which means that the alpha square plus omega square, or alpha square equal to minus omega square, this particular equation falls under a specific category. We call that alpha square is equal to minus of omega square. So alpha square is equal to minus of omega square. We can see the roots are as follows. Always you remember one thing. Whenever there is a chance of writing the function in this fashion, you will always get a chance. Okay, so that means we will be able to write the alpha is equal to plus or minus j into omega. So in this case, there is no real part. So real part is 0. Imagine that is omega j times omega into omega. Okay. Now, in order to simplify the equation, which looks pretty complicated. All right. So that means where a1 and so that means a1 a2 is constant, and the general solution can be directly written as y is equal to a e to the power j omega t plus a to e power minus j into omega t. So the values a1 and a2 are constants. So e to the power j omega t and e to the power minus j omega t, we try to substitute the function in terms of theta. So a1 is equal to, we can try to write e to the j theta is divided by r. Then we go to the next function, that is so e to the j theta can be written as cos theta minus j sin theta, and e to the minus j sin theta is, we can replace it as cos theta So we were trying to find out the value of e to the j theta and e to the minus j theta. We will substitute e to the j theta is equal to, so we will substitute it like this. We have e to the j theta, which is cos theta plus j sine theta, and we also have e to the minus j theta that can be substituted as cos theta minus j sine theta. Okay, now after this substitution, we saw that we can get the value of y as y is equal to, there was a1 into e to the j theta becomes cos omega t plus j sine omega t, and this next function, this becomes equal to a2 cos omega t minus j sine omega t. So we have a1 plus a2 cos omega t plus j times a1 minus a2 sine omega. A1 plus A2 we can call it as a sine phi. A1 minus A2 we call it as a cos phi, A cos phi. So you can see that the final equation is written in this way, which once again we can use the trigonometric identity over here. Okay, and the trigonometric identity is sine A cos B plus cos A sine B is nothing but cos of A plus B. Okay, so cos of A plus B, you can get this. So sine of a plus b is sine a cos b plus cos a sine b. We can replace it in this fashion. So y is equal to a sine of omega t plus phi is your final answer. Now a looks like the maximum displacement possible for this wavelength. Then the next value is, if we repeat the wave, we can observe that all the components of this particular waveform will repeat after some time. So the value of this y repeats when you increase the t by 2 pi by omega. So let's just verify that. So we write y is equal to sine of, see the original equation, that is omega t plus phi, omega t plus phi. So that can be simply substituted as follows. So I can write this is equal to sine of omega t plus omega times 2 pi by, right, 2 pi by omega, you can write this simply as 2 pi plus phi, out of which the basic rule is that the sine of 2 pi plus theta is sine theta. Okay, applying that, I'm writing the last term r, it's sorry, t is equal to 2 pi by omega, right, which is the period of the total vibration. And then we define the frequency of oscillation, which can be directly calculated as 1 over the time period, and the equation that we are going to use is omega by 2 pi. Okay, so this was the concept of the free vibrations. Mathematical representation also we completed. Now next we will go to what is called as a damped vibration. So free vibrations are actually ideal in the sense, when a body is executing its motion in a vibrating environment, its amplitude keeps on decreasing because of the resistive and the frictional forces acting on the body. Okay, so this is the practical case. So when a body executes execute vibrations, what happens? The amplitude keeps on decreasing. Amplitude keeps on decreasing, right? Why? That is because of it's because of the resistive and friction. Right. Now, the energy of vibrating body keeps on decreasing, and vibrations will come to null, or vibrations become null after certain amount of time. So the motion because of such vibration is what is called as the damped by friction or damped oscillations, right, in general. So what do you mean by this? It means as the vibration progresses, energy of vibrating body decreases. It keeps on decreasing. Okay, and the vibrations die out after some time. Now, so we'll look at the damped vibrations, whatever mathematics we can apply. Okay, so here we go for the analysis part of damped vibrations. Now, whenever there is a damped vibration, there are several things will happen. So in a damped oscillation, there will be a restoring force, right? So in in damped oscillations, there will be the first thing, it is called as a restoring force. There will be a restoring force, right? That is proportional to displacement. Restoring force proportional to the proportional to displacement and opposite in direction. It's opposite in direction. So that's why we know that particular force we are going to write it as minus of mu into y. Okay, so the F is equal to minus of mu into y. Okay, so I'll call this is the F1 is equal to this. In addition to this force, there is another force called damping force. Also, there is a damping force, and this is basically proportional to the velocity and oppositely directed. Okay, always damping is something like it's a resistive force. Okay, so proportional to the it's proportional to the velocity, and it is always opposite to this direction. So which is this direction? This direction refers to the direction of the velocity. Okay, so once we know all of them, we can directly write the equation, right? So F is equal to mass into acceleration. So that is nothing but m remains as mass. Okay, that is acceleration will be d square y by dt square, right? But now you see that uh, all the forces have to be equated somehow, right? So equation of motion of, therefore, equation of vibration can be written in the following fashion. The main force is nothing but mass into acceleration, that is d square y by dt square, should be equal to, so we can say first term is minus mu into y. But you think of a sine equation, the equation has to be written in such a way that it should consider the direction as well as the magnitude of, okay, of two things. So that means I have to write this as, so m d square y by dt square is the main force, which is equal to the resultive force, plus there is another force coming up, that's minus r into, we'll write differentiation of this, which is a velocity, dy by dt. So we always write, we try to convert this into a simplified format, that is, this looks like m time to, this can be written like, we'll bring everything to the same side. So that is m d square y by dt square plus mu times y plus r times dy by dt is equal to 0. So let's divide this by m and reshuffle the equations, that is d square y by dt square plus this is r by m into the, sorry, into dy by dt, okay, dy by dt, and the last term plus this is mu by m into y equals to 0. So now we can write it in the following fashion. So we know that mu by m is nothing but omega square. So we'll write, so this is equal to d square y by dt square plus r by m, I'm going to call it as a 2 into b, okay, 2b times dy by dt and plus the m by mu, we already have assumed this to be omega square, and then we write the y itself. Okay, so that's how we get this. Now the 2b is nothing but rim. So what is 2 by 2b is equal to r by m. We So what we do, we always remember this equation, and the mu by m is nothing but that is a omega square. Okay, now we have to assume different conditions over here. So the first condition is right. We have the equation given over here, so we try to assume the answer. Okay, so that equation is a homogeneous it's a homogeneous differential equation, right? So the solution, therefore we can write a solution by using the following notation. The y is equal to e to the power alpha t. Okay, let's call this as equation number 2. So now let the solution is like this. What we do, we try to substitute this back in the original equation. So that means I need dy by dt, which is equal to alpha e to the alpha t, and also we have d square y by dt square, denoted by, this is alpha into alpha, which is alpha square e to the power alpha t. Okay, all right. Then let us substitute these. Let's say this is equation number 3, right? Let us substitute this equation number 3 in the originally given equation. Okay, so that means when we take the terms out and when we try to simplify, so equation 1 becomes, say, first term is d square y by dt square, which is alpha square e to the power alpha t. Then plus 2 times b into, this is alpha e to the alpha t, plus omega square e to the power alpha t, equated to 0. So let us take the e to the power outside. Okay, so this is e to the alpha t into, this is alpha square plus 2b plus omega square equals to 0. Are you okay? Fine. Let's move ahead. This is the condition. I can say that e to the power alpha t cannot be equal to 0. This means the alpha square plus 2b plus omega square has to be equal to 0. So we'll find out now. Therefore, the roots are, alpha is my root. Therefore, the alpha is equal to minus b. So that is minus of the whole thing. So minus of, right, this is b, so this is minus b plus or minus root of b square minus 4ac by 2a. I can simply write it as omega square itself. So we have two roots. One is e to the power minus b plus b minus omega square, b square minus omega square, and next term is plus e. So therefore we can write, therefore the final answer of y will be a1 into e to the power minus b plus or minus b square minus omega square under root first one plus a2 into this is e to the power minus of b plus or minus b square minus 4ac. Okay, so that's the partial answer we are getting now. So in this case, with the a1 a2 are the constants. Okay, now let us say that there are some other values of the functions which we can actually uh, try to write it in a different way. So that will be written in the following fashion.